All right. Welcome to today's .NET Community Stand-Up, Managed Languages and Runtime. I am your host, Bill Wagner, who forgot to hit the Go Live button. I am sorry about that, everyone. With me are our two guests, Rich Lander and Chet Husk. Rich is a PM on the .NET team, responsible for containers and related goodness. And Chet is also on the PM team, responsible for the SDK work in containers. So as I start out, I'm kind of new to this whole container thing. Rich, can you give us just a good overview for everybody? Why is this so important? Why are we investing so much here?
Sure. Well, we're like almost 10 years into our journey on containers, so definitely not starting from scratch. Let's start with the problem to be solved that container solve. So before, what people would do is they would get a machine or a virtual machine, and then they would install a bunch of software on it, either manually or scripts. And so that was both time consuming, but also you would never have like a super, like, you could never reliably say this machine is in this state. And so what would happen is someone would forget to install something. You deploy the app, it would fail, or you'd try and deploy two apps together that would have slightly different dependencies, so those two apps would actually turn out to be incompatible. Or the last scenario would be, imagine that it was, it's like the Domino's Super Bowl situation where all of a sudden they need to get new machines deployed in order to handle the capacity of the Super Bowl. Not a football fan at all, but it's a good description. And so they want to very quickly deploy new machines. Well, it's like, okay, let's get a new virtual machine. Let's then run those scripts. It's all super slow, not reliable. So anyway, what containers do is they basically say, let's take the operating system, the dependencies, and the app and put them all into a zip file. If you think about containers like a NuGet package, and it's actually not that far from the truth. It's like, let's put everything into one file, and then we'll just deploy that as a unit. And then it actually solves all those problems that I just said, because you basically have, a zip file. It's a tarball, but a zip file that has everything in it. You deploy it to a machine that knows how to handle that particular zip file, and then launch it, and then you're off to the races. So that's the basic problem that it solves. There's a lot more to it, but that's it.
So containers kind of like a pseudo VM that gets run inside a VM or a physical machine.
Yes, although the key thing to think about is, people go down this container as a VM thought pattern. I still think it's it's both a good analogy and a bad analogy at the same time. The
Mm-hmm.
reason why it's a good analogy is, if you think of a VM as a VHD that contains a particular set of software, then that part is true. The part about it being virtualized in that sense of VMs, I think, is less helpful
Okay.
and takes you down some bad paths.
Okay. So what would be different? What's the good path to be thinking about it in that way?
Just think about it as a file that contains a single configuration of software, from
Mm-hmm.
the operating system all the way to the app. And then once you build that file, it'll always be that. It will
Okay.
never be something different. Whereas, again, with VHDs, they're so easy to mutate. VMs, they're so easy to mutate, such that, from Monday to Tuesday to Wednesday, they could change multiple times, such
Mm-hmm.
that you no longer have confidence in the software that they contain, and then you have reliability problems.
Okay. Okay. So so what is based on that? What is how does .NET play into this? Why are we doing things in the .NET runtime that makes it better for containers as opposed to just any old app?
Sure. Well, so I'll give this quick answer, and then I want to give Chet a chance to participate. Um, so yeah, so we started our container journey with .NET Core 1.0. That's when we first started to support Linux. Um, that was still relative because so this would have been like 2014, 2015, 2016 in that time frame. So it was still a little relatively early in on the container journey all up relative to where we are now. And so absolutely, if you want to have a Linux native dev stack, then it has to support containers. There's like not another option.
Mhm.
So we started producing container images, um, tried to figure out how to enable the workflows that users wanted, and everything just to kind of evolved from there, both based on customer feedback, the changing landscape. The landscape has changed a lot since those days, and then we had to make a bunch of changes into the runtime as well to make it handle like Linux C groups and stuff like that. And so it's like, yeah, this is the containers are a pre like it's just a necessary thing to do. It's like the not optional scenario for a cloud dev stack.
Mhm. So you want to leap in and add anything, Chet?
Yeah, no, just plus one on all that. The really exciting part for me, like from my end of .NET story of containers, is we've started like we started with an enablement mindset, right? Like we want to play in the space, we want to behave the way that containerization tech expects and get our first steps in there. And then after a couple cycles, okay, what is good about the way we've done this? What do we need to tweak? And that leads to deeper integrations with C groups and better patterns for deploying .NET applications in containers. And now we're at this third level, which is, okay, now we have some idea of patterns. How can we make the tooling do this on your behalf? And that's the exciting part we're at right now, where we're finally getting to where the SDK and our editor toolings can help you, the developer, benefit from like this year-long or multi-year-long journey we've all been on.
Ah,
Yeah, can I
okay.
just add one more thing, which is
Sure.
again, like why containers? Well, it also turns out that, in the public cloud, the container services are super popular. So, like if we just look at Azure, we've got AKS, ACA, App Service, also ACI. Those are all container-based services. So it would kind of suck if we built this .NET thing and customers couldn't use it in a lot of services in the cloud that Microsoft maintains. So I think we made some good choices on that front.
Okay. So how does this tooling work? Do we want to dive into that into what's so I hit .NET build. Okay, now what?
Yeah, go Chat.
Sure. Yeah. So the tooling side of this got really exciting starting in .NET 7, right? We unleashed the capabilities of the .NET CLI with respect to containers. And what this means practically for you as a developer is, and we will see a lot more of these later in Rich's side of things, but for a normal like web application, you don't need, I have some test Docker files in here, forget those, but you don't need a Docker file to create a container image for this application anymore. You can very simply do one single command. Let's say default container. You can do one command and get a Docker container. And so this is sort of like the workhorse that we've been building editor integrations on. This isn't just constructing the container. This is using all of the information that MS Build has about your project to build, the best and most compatible container that we think you can. So some interesting things to call out here. This is a web application. We're using the ASP.NET base image. we're using the version of that image that matches the SDK that you're using. And by default, we went to your local Docker registry. And so if we look at that image in the Docker tooling here, you can see this is, a fairly, standard image here. Here's the layer that we created, and all the rest of this we inherit from all the work that Rich's teams do making the base images for us. That took, 10 seconds? And we had a perfectly production-ready container with no other files. And that's sort of the elevator pitch for the tech, and why I think it's a great stepping stone to building more connected experiences.
Okay, so with what you built there, that default container publish profile, I probably get the name a little bit wrong. So is that built in, or is that something I have to create for my app?
For web apps, that's completely built in. You could .NET new web and then cd into that generated directory and run that same command and get a container. Now your name would be different because we infer some properties about the container, but all of that is something that you as the user driving this thing can control through MS build properties. And we have comprehensive docs about how to do that. My favorite question. Can the same be done through VS? And the answer is yes. Because we built the tech on top of publish profiles, VS natively understands this. You can right-click publish on a web application in VS, and it will walk you through a series of steps that you can do to choose where to publish the application to, which can be Docker Hub, Azure Container Apps, or any compatible container registry. And then critically, it will ask you how you want to do that containerization. You get two methods there. By default, you will use the same command that I just used, the tooling built into the SDK. But you can also choose to use Docker files, at which point VS will scaffold out a Docker file for you. So it's fully supported in VS from a publish perspective there.
Can we address that? Jeremy has a good question.
Yeah,
our good friend Jeremy.
Yep.
Yeah. Can you address that one, Chet? It's a really
absolutely
this one gets asked all the time.
It's a very astute question. So it's kind of a fine line to draw here. So for the default use case, the command that you just saw me run, I didn't specify a destination for my container. So we assumed you wanted to go to some local daemon, right? So we prefer Docker, but thanks to a partnership with our friends at Red Hat, we fully support Podman here as well. So if you're on a Red Hat image and you run our tooling, we will write that image to the Podman binary that you've got available on your path. So for the local push, yes, we have some features coming down the pipes. Again, community contributed. There's a big thriving community around this that will let you create that image directly as a tarball that can be imported via Docker load or Podman load or whatever you want to do with it. So broadly, we're only reliant upon Docker for sort of the default dev inner loop scenario. You can also push directly to container registries without having Docker on your local machine.
Okay, so we had another quick question based just on the demo that you did, Chet. Does it expose specific ports on the default container?
Yes and no. So it does expose specific ports, but as of about a month and a half ago, it no longer exposes them in a hard-coded manner. So actually, I can show this. So one of the cool things about containers is, let me go get the name of my container here. Sorry, I'm knocking my water all over the place. Let's just look at what ports. So this is a command that lets me sort of pull out specific parts of the container metadata. And so I've done that, and I pulled out the exposed ports, and we see that we have exposed port 8080 on TCP. Why have we done that? Well, that's because the image that we based ourselves off of, the .NET/ASP.NET image, somewhere along its pipeline actually set that exposed port. And actually, we can see that in the Docker tooling here. Right here is the layer that came from the .NET Runtime Deps base image that sets a user ID, the HTTP port for ASP.NET Core, and a few other pieces of environmental data. We are aware of that in the tooling, and we're data driven. So starting in .NET 8 and going forward, if you override the HTTPS port on your base images or in our tooling, or if you set a different app user ID, and these are standard mechanisms that we sort of expect all .NET base image users to use, then this tooling will just work with whatever customizations you make.
Okay. Cool. Now, let's add this one, which I think is an interesting one, right? So can we run tests using this same kind of mechanism?
It really depends. And this is an area that we don't have strong practices around and strong guidance on. Depending on how you've architected your tests, this tooling can help or hinder you. So if you look at a typical multi-stage Dockerfile build that somebody might have for a project today, you'll first have the build aspect, and then you'll copy the build aspect to like a test stage that runs your tests, and then you'll have a publish stage that publishes the app, and then finally an application stage that copies the published assets from the published build into the final runtime container. It's a lot of different stages, a lot to keep track of, and that's part of the reason we made the tech in the first place. If you are running the tests in the Dockerfile build, this is not a good fit for you. I would encourage you to consider other pathways like building the application into a container and running your tests against that container if you have an HTTP service or something like that. That also gives you something that you could potentially run against your production deployed or staging deployed instances to get some more confidence on. But it's an area that we are evolving our thought process on, and would love to hear what you all come up with to solve this, because it's not a solved problem.
So I think there was kind of some interesting layers underneath that. And then if we don't mind drilling down just a bit. So when you said basically I'm be running tests against my container, if I think of the difference between, say, unit tests or something of that nature, and an integration test actually hitting port 80 or whatever ports configured and running that whole pipeline, like I think of the difference, like when I build Roslyn, I submit my changes, right? Because I'm only running like some of the unit tests on my machine on the stuff I actually changed, and then I'll just open a draft PR and let it run, the umpteen configurations and the thousands of tests and so on in the cloud. But it's all unit tests, right? So what you were talking about, Chet, there is more of I'm going to actually build the container, and then I'm going to run basically automated integration tests by hitting that port. And that's where this tooling is more valuable then. Yeah.
Unit tests, I would say you've got a couple options there. Like, because this tooling packages a container for some potentially a different architecture, if you have confidence in your unit tests, you could just run, .NET test in your CI pipeline outside of containers. Like, what value are you getting from running your unit test in the container at that point? Mm-hmm. So that's kind of the trade-off in my mind there. But that is my opinion. That's not a.
I can provide some insight on this too. So I wasn't able to post this in the chat here, but I posted it through the YouTube thingy. So hopefully people can see it. So we did an experiment. This is like ages ago now. Okay, yeah, looks like it got posted. That's awesome. Several times. So basically, when we started doing all this stuff, we did look at testing, unit testing, and I think that's what's being asked about by the question, since the Dockerfile was mentioned. And so the thing that we realized is testing in the Dockerfile in the natural way is not super good. And the reason is that if the tests fail, it means the Docker build will fail, and then that means you don't have access to getting the log to like figure out what happened in a programmatic sense. And Docker build doesn't support volume mounting, so there's no really good way. There's no good way to get it. So instead, what we did is we came up with a pattern, which is at this link, where what you do is you use multi-stage build, and so one of these stages is a test stage, which in the default run of Docker build doesn't get exercised. So if you just type Docker build on your Docker file, you get an image, tests don't get run. If you want to do a test run, then you build to that stage, and then you do Docker run on the image that gets produced. You then do volume mount the directory where the test log file will get written. And then the running of the container will not exit just because the tests fail. That's a Docker build characteristic. So then you'll absolutely get access to the test log. You can make the container run as long as you want. It just offers a ton more flexibility. It's still all in the Docker file. So you still have only one file that describes all of your kind of like pipelines, but it gives a lot more flexibility. So that's what I would recommend.
Okay.
If you're going the Docker file route for unit testing. Okay, Jonathan says that is exactly what we're doing right now. So awesome.
Okay.
Great minds think alike.
And then there was one other question directly related to Chet's demo, which is right there. So great, you just showed me on a new project. What about my favorite project that already exists? Maybe I built it with .NET 7. Maybe it's .NET Core 3.1, and I've been upgrading ever since. What happens now?
Yeah. Well, first off, big banner warning: 3.1 is out of support.
Right.
I've
been upgrading since then. I've been keeping up.
Yeah. So this works just as well with existing projects. From the 70400 SDKs onward, every web project just has this capability. The only thing that materially changes between a Net 7 targeted project and a Net 8 targeted project is the tag used on your base image, as well as the inference of what your user ID should be or what your port should be, right? Because those are different pieces of data on the 7 base images compared to the 8 base images. So it works perfectly well with existing projects. We've been focusing on web projects so far in today's talk, but it also works with console projects as well. You have to add a NuGet package in that case for today. But yeah, if you can publish a project, well, I'm going to take a step back here because UI projects don't work especially well with Docker. But in general, console and web applications should just work with this tool.
So that would include my Azure Functions projects as well.
Yeah, 100% should. So there's some caveats there because a lot of the functions providers tend to have a lot of their own bespoke tooling around getting your project into whatever shape that they want for their deployment models, right? So there is probably some massaging that you will have to do to get it into that shape if you use our tooling today. But part of my sort of overarching mission for this tooling over the next several quarters is to work with those teams across, companies, across orgs to smooth that path and make it truly drop in.
Okay. So we had one other unanswered question so far. So go ahead and add some more. I think Richard had mentioned Podman as part of that.
No, Chet mentioned it.
Excuse me.
Yeah, so what was me muddying the waters? Yeah, pros and cons. Podman is a daemonless system. That is, I think, the most stark difference that comes to mind between it and Docker. They have similar CLIs, and for basic use cases should behave fairly similarly. But Podman, like I said, doesn't have a daemon, so there's no persistent process that goes on there. And it has sort of, I would say, more strict opinions about the way that you should name and interact with containers. For most folks, like for simple usage, there won't be any difference, but it's sort of preference for devs. Like in production, you're not going to be using either the Docker engine or Podman's engine, right? You're going to be using something like Containerd or Creo or something more bulletproof. So,
well, so I wouldn't word it quite exactly that way, because like Docker uses containerd as well.
yeah,
So
you're right.
what I would have said, what I would have said is, at production, you're going to be using something like Kubernetes. That is the more analogous thing. So Kubernetes obviously brings a ton more stuff into play, because it's this like crazy orchestrator type system. But yes, most people do not use Docker in production. Yeah, Docker, Docker, this is where it starts to get really complicated. But, we have Docker Desktop. That's what most people are using for dev. Docker Desktop is not used in production at all. Then we have Docker EE from Mirantis. Some people use that in production. If you only want to run primarily one app, or you want to use Docker Compose or Docker Swarm or something like that. But if you want the microservices lifestyle and use multiple containers at once, then that's how you end up with Kubernetes.
I will say one last pro con of Podman. It does not have the breadth of support in Compose as Docker does, right? Docker Compose is really, really handy and useful and full featured, and there's not parity between the two, not 100%. So keep that in mind if you
Right.
experiment with Podman.
Right. So we should switch a little bit to, we made some major changes in .NET 8 that I'm sure the folks on this call would want to know about.
That would be awesome. So it's
yeah. How about you tell them, Chet? See if
the major changes.
What did we do? Yeah.
Oh
what did
Lord,
we do?
what didn't you do? So the biggest thing is you enabled rootless execution of containers. I think that's the biggest umbrella to sort of categorize some of the changes under. And that involved, I think, two things primarily. One, changing the sort of user that the application can run under. And the second is ensuring that the port that is exposed by default for ASP.NET is one that is capable of being used by a rootless user. The old default of 80 required privileged Docker runtimes and privileged user permissions to use. How'd I do, Rich?
Good. Yeah. So people sometimes get confused, even on our own team. The user in all of our images by default is still root. It's always been root. It will continue to be root, but we added a user that you can optionally use, and we can demo that shortly. Yeah, so that was one big change, and we hope people now, the friction to adopting non-root container hosting is now dropped to almost zero. So there's kind of no reason not to adopt it. Where was I going with that? So that was it.
so I'm actually curious about that one then. So my biggest use of containers, I kind of mentioned earlier before we were on camera, is just that our team has a number of GitHub actions that are executing a .NET console app, right? So the action is configured. It's got a Docker file, builds a container, builds a app from, our latest tagged branch, and then runs the thing, and then goes away. So would we gain anything from not running that container as root? Is there any of the, there's some known security concerns around GitHub actions, especially if they run in forks or something like that. Is there anything there that would help us do this more safely that we should start adopting?
Well, it's really defense in depth is the way to think about it. So it just means, I would liken it to driving a car without a seatbelt. So 99% of the time, I drive the car, in the city, on the highway. I don't actually need a seatbelt, because nothing happens that ever suggests that the seatbelt was needed, right? I'm not getting into a car crash. So how that relates to containers is, you could pull in a bad dependency that basically puts your container image at risk in some way that you currently don't understand, right? Because you can't predict the future. So running it as non-root is like that seatbelt that gives you a whole layer of protection when it's needed, and you can never predict when that is.
Okay, now that makes good sense. That's
that's literally what the whole concept of fence in depth means.
Right. So it is arguably better, shouldn't hurt us in any way, and protects us against some things we may not be thinking about right now.
Right, but think about it on your computer. So your own desktop computer. So Windows moved to standard users, like back in the ancient times, when I was much younger. Everyone ran as admin. Like every Windows machine was run as admin. Most of the time that wasn't a problem, until it was, and it definitely did turn out to be a problem at times. It's like, Slammer, Melissa, whatever all those viruses were, Trojans. So then everyone moved to standard user as a defense in depth measure, and we're never moving back, because it's necessary for desktop computing to be safe to run a standard user and have very specific workflows to elevating. All the operating systems run that way now, which is very, very, very good. This is exactly the same thing. Like, not kind of the same thing. This is exactly the same thing.
Okay, you've got me convinced.
I do just want to point out that with the SDK container tooling, we do default you to operating in rootless user mode for .NET 8 applications starting up. So we've got that documented. It shouldn't, it's not something we're trying to hide. It is our opinion that the tooling should guide you to the safest default, and we think that is just a safer default in this day and age.
Okay, so maybe now is a good time for me to do a demo. Does that?
Oh yeah, absolutely. We've got about 20 minutes left. I've got a couple questions tagged for answering later. So yeah, we're good. Let's go for it.
So you can switch, or do I switch or you switch?
I think I do. So you want your screen up there now? There you go.
Okay. So let's show this.
Can we make that font a little bigger?
Yeah. I'm going to.
Okay, thanks.
Okay, let's see where I was even at here. Okay, so my favorite .NET app. So let's look at this Docker file. Actually, we can bring it up in VS Code. Okay, so this is a super simple app, and it doesn't matter what the app does. Actually, let's look at the Docker file. So actually, there's one line that is important. This we're setting the user. So I'm actually going to run it the first time. Let's comment this out. And then I'm going to make this a little bit bigger. I'm going to run docker build -t app. That should run pretty quickly because I did this earlier. Okay, so now we're going to run it. Did I call it app? I hope so. Okay, so this is basically, this is like a diagnostic sample. So you can see, I'm running on ARM64. The default image is Debian 12. This is RC1. But the really interesting thing is we're running as the root user, which I just told everyone was terrible. So let's put this back in place. And I'm going to explain.
Shout out to Jeremy for noting that it was ARM64.net.
Yes. Jeremy loves that. Yeah, this is being run on a Mac. Although, again, another thing some people get confused about is when you're running on a Mac, the thing that's inside the container images is still Linux. There is no Mac operating system that runs in containers. So let's run this again. This is the normal way because, like I said, I commented out before, it ran super quickly because of Docker caching. The only thing it needed to do was change the user. So let's run clear again. So let's run the app. And now you can see I'm running as this specific user app. And so now I just want to explain one thing, which is what the heck is this app UID thing? It doesn't say app there. It says app UID. So it turns out that here you can either specify a username by its name, like app, or you can specify it by its numeric value. And there are some certain scenarios in Kubernetes where the numeric value is super useful to have specified. So as a result, we just decided to always specify the numeric value. And so if I do something slightly different, I can show you what that numeric value is. So if I do docker run entry point bash, and then app, and then we can do minus C. Now I'm just doing this. Yeah, if we just do this, this should work. Yeah. So here's that app UID. So it's specified to this numeric value, 1654. And then to show you what that is, let's do cat etc / password. I think that's where this is located. Password grep app. Let's see if this works. Yeah, okay. So there's actually, let me just get rid of this so you can see the whole thing. So this is the password file in this particular container image. You can see root here. It's the first user listed. There's a bunch of other crazy users that come with Debian. And so here's the user we added, which is app. And so its numeric ID is 1654. And like I said, I don't want to go into a great deal of detail, but there's Kubernetes scenarios where specifying the UID, user ID, instead of the username is beneficial. And so that's why, back to VS Code, that's why we have this environment variable specified instead. And like I showed you, this environment variable is defined in all of our container images so that you can do all of this easily. Okay, that's all I wanted to show, at least at this. Actually, how about I show, let me just show the ASP.NET version as well. Okay, so basically the same thing. Let's look at, let's not do Debian this time. Let's do chiseled. Chiseled. Okay. Oh, what the heck? Oh, right. Chiseled is a scenario where the user is set by default, so that's why you don't see it here. If we went to here, the Debian one, you'd see that it's the same line as before. So anyway, let's run this. Docker build -t app -f dockerfile.chiseled. Hopefully this won't take too long. Building the app. Okay, here we go. So now we're going to, here, I'll just do clear again. Just get rid of that. Okay, should have closed Teams. Okay, so we do Docker run. Now we have to set the port. Oh yeah, this was a good demo to do. So I was like running it as port 8000 on my local machine, but it's port 8080 by default in the container image, and then we do app, and then we go back to the browser. Actually, I'll open it up in this one so that we don't get the team stuff. Localhost, 8,000 environment. Cool. Actually, Edge does a slightly nicer view of this, but this is just some JSON, and you can see here.
Can you zoom in a bit? Yeah, there we go.
Yeah,
now
yeah.
We can see there.
Yeah. Now you can see in the JSON that's output that we're running as app, and this also has a web view. Now we don't need it quite as big, so you can see we're running on Ubuntu. Go ahead,
Rich. You mentioned that this was the chiseled version. That's not like a Linux distro I'm familiar with. Would you mind sort of talking about what chiseled are?
Yes. So chiseled images, if you're familiar with Distroless, chiseled is basically the same thing. It's the Ubuntu version of that. And so just to, let's do a couple, so the whole thing of chiseled is it has a couple of value props. One is that chiseled images are incredibly smaller, and the other one is, by virtue of being smaller, they also have a lot less attack surface area, a lot less components to have CVEs in, so the management of them is a lot better. So let's show what the value is here. So we'll build, we'll call this Debian app, and yeah, that should do it. We'll just build this twice. Like I said, I built these before, and we'll call this Ubuntu chiseled app. Okay, now let's look at Docker images. Some of these will be the wrong thing. So you can see that, oh crap, that's not right. What did I do wrong? That doesn't make any sense. Just a sec. Where's T? Oh, never mind. Ignore app. Yes. No, this is all correct. So you can see for this app, the chiseled version is 124 megabytes. And when I used Debian, it was 257 megabytes. So chiseled saved us, it looks like 130 megabytes. My math is correct. For free. Like, not only was there no downside, we actually got value by using chiseled because there's just less there to worry about.
Now
so this is another defense in depth thing.
Now that savings, is that just an on disk savings, or is that also an in memory once it's loaded savings?
It'll be a little the on memory. Sorry, so there's actually three. We can actually go back to the you can go to the main screen now if you want.
Okay.
Yeah, so we can just talk about this. So there's like at least three sizes that matter in container land. There's the on disk footprint. So that's what we call uncompressed. That's what we were just looking at. There's the compressed footprint, which is when your container image is sitting in the registry, that's in the compressed state. When it's being downloaded over the wire, either to your local machine or to your production container host, that's the compressed size, which would have been obviously smaller than those numbers. And then there's the amount of in-memory goo that gets loaded. So this difference that we just saw absolutely affects the first two scenarios, on disk and on the wire or in registry. The in-memory state will be affected a whole lot less by this particular difference. It's not like every single byte that's in those images is loaded into memory before the app is run or anything like that. So it will have a relatively meager effect on memory in your container host.
Okay, so I had a few questions before we wrap up. Kind of a two-parter here. Chet mentioned Visual Studio generating a Docker file. Is it possible to do the same from the CLI? Can we get the Docker file instead of the image? And his reason is that there's cases when we're asked to provide the Docker file rather than the actual pre-built image. So I'll go back to the sort of question part there rather than the scenario.
Today, no. You cannot do this with the tooling right now. It is the kind of thing that should be very easy to do, though. Both VS and VS Code, the editor tooling for both of those, just have a kind of rich templated experience where they are inspecting your project's properties and then filling those properties into a template. We should be able to do the exact same thing. It's just not a thing that the team has gotten to on the backlog yet. It's definitely one of the issues in our backlog that is marked, up for grabs. So if this is a blocker for you and we haven't been able to get to it yet, we would love to work with you to get it implemented. We know that Dockerfile-based deployment systems are very prevalent, and we need to have an answer there to be able to fit the tech into those worlds. Right?
So which of the many .NET repos is this SDK in, so that Seraph can get to that? I'm honestly not sure myself.
So a lot of the stuff that I've been showing is documented, and we have issue backlogs and that sort of thing at the one URL that I have not gathered yet. I had my list of URLs.
That's okay.
Making a banner right now. It's here, .NET /SDK container builds. The actual code is in the proper SDK repo, but we should talk here first before anything happens. Okay. But a lot of the stuff that Rich has been showing is in the .NET Docker repo, which is a different place, and you can find all that there.
Okay.
That's the sample specifically, but start there.
Awesome. And then last couple questions. We had one just coming in. Should I move from .NET 7 to RC1, even if I don't plan to release until 2024? So for reminders that November is the scheduled, GA for .NET 8.
Yes.
Rich,
there's no reason to wait. Get onto the new train. You get to use new features. I've already started using C# 12 features. That's the version, right? C# 12.
Yes.
Collection literals.
Yeah, that's actually probably the feature I use the most, is collection literals.
I think that's true for me too. I'm finding I'm slowly growing an affection for primary constructors in a lot of places.
I've started using those too, actually.
Yeah. I'll even just answer this one. No, not now. There's a lot of discussion in the C# Lang repo because there are two obvious answers and they conflict with each other. The first obvious answer is make it an array because it's a collection. The reason that's not a good one is that forces an allocation. The other obvious answer is make it a span, which is great unless you're using it in a place where you can't use a span, or if you actually want to add something to it later. So it is something that we're going to continue to revisit and try to get a natural type for any collection literal expression, but it's just not solved yet. We didn't like any of the answers we had. We had one other one from Jeremy. Does this work with Windows Subsystem for Linux in Windows ARM 64?
What is this in this case? If you're talking about the SDK container building, 100% yes. One of the big upsides of that is the SDK is very platform agnostic, right? It enables you to build across platforms and across RIDs, left and right and upside down, and twice on Sundays. That is also true for these containers. You can target, you can be on Win ARM64 and target not Win x64, but like Linux x64, Linux ARM, with no loss of fidelity. It's all just configuration and your built outputs for your project.
Well, let me ask a clarifying question about that, Chet, which is, what can you use? What happens if you don't have a Docker desktop-y type solution installed. Like, so I can't remember if Windows ARM 64 has a Docker desktop solution yet, or if you're using WSL and you just didn't install anything through WSL or on the Windows side, what happens?
Sure. So you would not be able to push to a local Docker daemon in that case, but you could still use the SDK to send that container image to an Azure container registry, Docker Hub, any of the container registries that follow the OCI open standard.
Okay. And then we had one nice one to close on, which came quite a bit earlier. Is there a single place where we can find all of this? I'm assuming they mean the containers, container registry, and so on.
Yes.
Yeah. So the answer is not exactly. So one of my tasks for the fall before we ship is to update the container docs, and then make sure all of this is there. So that is currently not the case, sadly.
Mm-hmm. And then
I would say
I agree.
Yeah. And I would say as that happens, if you look at
a good resource.
Yeah, and I'd say as Rich gets that done, if you look at the just what's new in .NET 8, that should at least be one click away from where all of this lives, along with all of the C# 12 changes and all of the other enhancements in like everything. Should be one click away from there. Here's what our goal is. So,
yeah.
Anything that you two want to finish with? So we've pretty much hit time. Awesome. I've actually learned more about containers and stuff than I did before we started. So
yeah, I mean, I think my ending statement is we've been investing a ton in containers for close to a decade, and I would say our investment level is actually increasing. We see that this whole modality is super important.
Okay. And with that, I'm going to say thank you unless you had anything to add, Chet. It's just so you kind of nod in agreement there. Okay. And then with that, I will say thank you very much, everyone, for attending, and we will see you next time.